comma what?
Negative 1.
Okay. This point is on this curve, right? 1 comma negative 1 on the curve.
And now
Yeah. Go ahead.
Now you look at, you plot that on a graph and you see where that slope, where you draw that curve, or imaginary curve, whatever function there exists.
Okay.
So you can plot that point 1, negative 1.
So if we go over to 1, negative 1, then there's a curve there.
Yeah, so we then draw a linear line as the representative tangent.
Wait a second, all lines are linear.
Huh? All lines are linear?
Yeah, you said linear line.
Oh, just like that's what I meant to say.
I'm struggling, Rush. Go ahead.
So we know it's a cubic function, so it's going to face downward. It's that negative sign, right?
Cubic or quadratic?
I mean, a cubic, quadratic.
Okay, quadratic.
So it's going to be shooting upward with the slope of 1. You see what I mean?
I see what you mean, yeah.
Now we just got to use an equation with the derivative, what is it called? F of x minus f of a, or yeah, f of a, f function of a plus h minus f of a over h.
Okay, so Raj has given us a picture of this thing. He says that it's a quadratic moving downwards, and it goes through 1, negative 1, which would be this point here, 1 comma negative 1. Okay, so we want to find the tangent line there, and it should have a negative slope according to the picture. Agreed? Okay, so once we find the slope, to construct a line, what do you need beyond the slope? What's that? How many? If I have a slope?
Oh yeah.
Right. If I have a slope, I only need 1 point, correct? You either need 2 points or a slope and a point. I'll have the slope, because the slope of the tangent line and the slope of the curve are the same thing. So the derivative will give me the slope, and then I need a point. Where am I going to get the point from? Right there. They intersect in the same place, right? So the 1, negative 1 is both a point on the curve and is the point on the tangent line at the same time. Don't forget that. Many people forget that for a reason when they first start taking this class. Okay? So take the derivative. The y prime is negative 6x. Where do we want to know that value? At 1, right? What is the slope when x is 1? So I need to find y prime at x equals 1 is how you note that. So that equals negative 6 times 1 is negative 6. And it does have a negative slope just like we suggested it should.
Where'd you get negative 6?
I don't know. The derivative. I pulled the 2 down.
Oh, okay.
How? That's gone. That's right. All right.
So we don't need to do the equation that we were doing.
We don't. That's why we have the rules now, to avoid having to deal with that limit definition. So now we know the slope of the curve at 1 is negative 6. If that's the case, then y equals negative 6x plus an unknown y-intercept. To find the y-intercept for the equation of this line, I will plug in x is 1 and y is negative 1, since that is the point that it shares with the curve, and solve for b. Standard find the equation of the line problem, that's it. So plug in negative 1 for y, you plug in 1 for x, you find that b must be what? 5? B equals 5. So the slope of the tangent line is negative 6, and the equation of the tangent line is negative 6x plus 5, which is reasonable from the picture. Matter of fact, it is exact. Look at that. Woo, right there at 5. Pretty good. There at 5, just like I figured.
Why do we have to find the x? Why do you have to find y-intercept? We're just looking for.
I want the equation of the tangent line now.
Oh,
I want the equation of this whole tangent line is what I'm looking for. Very standard problem in this class.
Since it's a linear, it's a line going straight up down, it'd be y equals x plus b.
Yeah, that's the usual way you represent a line. It's y equals x plus b. There are other ways, but that's probably the most commonly used way. Okay? This problem makes sense? We want to be on slope to equation of the line. One more from this section and we'll move on. Or we'll take a break perhaps.
Wait, I have a question.
Yes.
Sorry.
Yes.
So, y equals negative 6x plus 5, you said it was the tangent?
Line. That's the line itself now.
Okay.
Not just the slope, right?
Okay.
All right. Okay. Next most standard problem you'll find in this class, or some variation of this, is finding slope locations like 39 through 41. Would be 41. Find all points on the graph of f of x equals 3x squared minus 12x plus 4. 4 of that curve where the tangent line is horizontal. This is the most important question in the class.
What's a print?
What's a what, Jewel?
Oh, does that say points or prints?
Oh, come on, you know what I'm saying. don't give me that. I understand English business.
Yeah.
Point.
I actually wrote prints.
That's fine, that's fine. Do whatever you want for now. The reason this is an important question is because it's going to come up in many different guises over the rest of the course. And I'll tell you now why it's important, just to hint at things we're going to do later. So, in general, let's just draw a silly curve here for a second. The tangent line is horizontal whenever it has a slope of 0. So I guess right about there and right about here. That's where the tangent line is horizontal, correct?
It's basically just finding all the points and maxes.
That's the important thing, exactly. Yeah. Finding min and max is extremely important. When you're talking about money, you want to maximize. You talk about labor.
I thought you said Boston.
Maximize. Okay, minimize.
Maximize profit, minimize expense.
Exactly.
Economics.
Your maximum would be your y-intercept.
No, of what?
Of this equation.
Of this equation? No, because this one is not centered at on the y-axis. It's been moved around significantly. Oh, sorry, it's not even a quadratic now. It's very complicated to say where the maxes and mins are. And this one has no absolute max in the first place. There's no absolute maximum. All right, so what do you have to do? I kind of gave it away. What do you have to do? Well, that's true, but how? Find the derivative and do what with it? Set it equals 0, right? That's where the tangent line is horizontal, where the derivative, the slope, is 0, right? Okay, so take the derivative. What is it? F prime. What's F prime? Tell me, Chan, I can't hear you.
6x2 minus 6x minus 12.
And we want to set that equal to 0, right? Where the slope of this curve is 0. That's where the tangent line will be 0. Okay, so they give us something fairly straightforward. We just factor off the 6. So 6, we have x squared minus x minus 2 is equal to 0. We can now factor, because 6 times x minus 2, x plus 1 equal to 0. So therefore, x equals negative 1 or 2. Those are the two locations for x where the tangent line is horizontal, which means, in this case, where the curve reaches local maxes and minimums, local ones, not necessarily absolute ones. A little fluctuation in the curve, right? Okay, if you need to find the y value, just plug it back into the original function. Where are your original functions?